Hello everyone. I'm Amol Boite, Principal Solutions Architect at YugabyteDB, and I'm excited to be here at DSS 2025. Thanks for joining. I'm here to walk you through something interesting, a topic on how AI and relational data are coming together to power next generation of smart, scalable apps. We are witnessing a shift in the industry. AI is no longer just about isolated machine learning models or analytics. Today's businesses want real time intelligence, whether that's smarter search, personalized recommendations, or catching frauds as it happens. But here is the problem: most companies still use separate systems, one for traditional SQL, another for vector search. That means more complexity, more silos, and slow results. That's where YugabyteDB comes in. It's a distributed Postgres compatible database that brings SQL and vector search together in one powerful platform. You can run hybrid queries, combine structured data with embeddings, and scale it all effortlessly across regions. In this session, I will show you how YugabyteDB helps simplify AI apps while still providing the resilience and scale that modern applications need. Today, we will cover the challenges of managing both relational and vector data of AI workloads and why a unified approach matters, how YugabyteDB combines distributed SQL and advanced search in a single scalable platform, an overview of YugabyteDB, then how to run hybrid SQL and vector similarity search in a single query. Then we'll see the comparison of YugabyteDB to traditional vector databases. Finally, we'll see a real world use case and live demo of a hybrid query. So let's move on. In the first section, we will see how enterprises face the challenges of managing both relational and vector data for AI workloads, and how YugabyteDB unifies distributed SQL and vector search in a single scalable platform to solve this problem. Before we jump into the main topic, let's first spend 2 minutes understanding what a vector database system is. Whether you are new to vectors or already know, this slide will be a quick refresher for you. This will be a foundation for the concepts and demos we will explore today. Across industries, organizations are experiencing an explosion of unstructured data such as documents, emails, chat logs, images, and audio. Traditional databases are optimized for structured tabular data, but the real value in modern AI comes from making sense of this unstructured information. This iceberg visual illustrates a compelling truth. What we see as structured data, the tip, is likely just 20% of data organization generate, and the rest 80% or more is unstructured or semi-structured data, that is dark data. Most organizations struggle with data scattered across structured, semi-structured, and unstructured formats. YugabyteDB unifies all three, natively supporting SQL tables, JSON, and PG vector-powered semantic search. Structured data includes things like transactions and inventory. Semi-structured data covers JSON logs and event data. Unstructured data includes emails, docs, and chats. Those are rarely analyzed but full of insights. YugabyteDB lets you manage all of it in one distributed platform without extra tools. What is powerful about modern platforms like YugabyteDB is that they allow you to store and index these embeddings alongside your relational data, supporting both structured and unstructured workloads. This enables advanced use cases like semantic search, retrieval augmented generation directly within your enterprise data platform. Let's talk on the typical vector database system and how vector creation happens. In this diagram at the top, we see the vector creation process. It starts with uploading documents, which could be anything from articles, PDFs, or internal knowledge bases. Each document is then chunked into manageable segments. before being passed to an embedding model such as OpenAI or Hugging Face. The model outputs a high dimensional vector embedding for each chunk, represented here by colored arrays, for example, cat, kitten, dog, and so on. These embeddings capture the semantic meaning of the text and are stored later in the vector database. Below that, we have vector search workflow. A user submits a natural language query via an API or orchestration tool like LangChain. That query is similarly converted into an embedding search using the same model. This query vector is then sent to the vector database, which uses approximate nearest neighbor indexing, such as HNSW, means hierarchical navigable small world, which is one of the most popular and powerful approximate nearest neighbor algorithms used in vector databases to efficiently and find the stored chunks. Those embeddings are closest in vector space. The result is a set of semantically relevant document chunks, enabling RAG-style retrieval or recommendation tasks. In essence, this shows the RAG pattern where data is embedded into vectors, then indexed for fast semantic search. It highlights how vector search powers real-time context-aware results. We'll explore how YugabyteDB supports and scale this natively, combining it with relational SQL and global resilience. Let's see the AI data challenge. An organization embrace AI. The nature of data workload is rapidly evolving. Modern AI applications like semantic search and RAG require not just like traditional transactional data, but also high dimensional vector data for similarity search and embeddings. Historically, enterprises have managed these needs by deploying separate systems, a relational database for business transactions, and a dedicated vector database for AI workloads. While this approach works at a small scale, it quickly leads to significant challenges as data and usage grow. The challenge with separate systems is complexity and overhead. Two platforms mean more sync, more code, and more chances of errors. Scalability suffers with high cost and added efforts to maintain availability across both. And innovation slows down as teams juggle different tools and APIs. What's needed is a unified, scalable database, one that handles both relational and vector data efficiently. That's exactly where YugabyteDB excels. These diagrams on the right side says traditional versus unified architecture. Traditional setups use separate SQL and vector database, likely linked by ETL pipelines, adding latency and complexity. With YugabyteDB's unified architecture, both SQL and vector workloads run in a single distributed database. Thanks to native PG vector support, there is no need for syncing or managing multiple systems. The result is simple, faster, and more scalable solution for modern AI applications. Let's see YugabyteDB overview and how distributed SQL meets vector search. YugabyteDB is an open source distributed SQL database built on Postgres SQL that combines strong consistency, high availability, and no SQLite scalability. It uses a shared nothing architecture with Raft for shard level consistency and linear horizontal scales. Reads and writes are distributed across nodes. With native PG vector support, YugabyteDB enables seamless storage and querying of vector embeddings using standard SQL, making it ideal for AI applications like RAG and semantic search. It supports geo-distribution and delivers low latency, resilient operations globally. This architecture allows AI apps to run transactional and vector queries from one unified platform. Vector indexes and relational data scale together, enabling fast, secure, and enterprise-ready AI workloads, all without separate vector databases or complex sync pipelines. Let's see how YugabyteDB's vector indexing and distributed SQL work together. YugabyteDB extends pgvector to offer native in-database vector similarity search. You can run combined vector and relational queries with support for distant metrics like cosine, Euclidean, or inner product. It is built for scale. Vector indexes are automatically sharded across nodes, enabling high throughput and horizontal scalability. The pluggable design supports future integration with new indexing libraries. Finally, it inherits YugabyteDB's core strength, that is fault tolerance, high availability, and geo-distribution, ensuring low latency, reliable vector search across regions. This makes YugabyteDB a powerful foundation for distributed enterprise-grade AI applications. This slide shows how YugabyteDB handles scalable and performant vector search using a distributed shared nothing architecture. At the core of this architecture is a Vector-LSM, that is log structured merge storage layer, which is a modular purpose-built system that decouples vector search logic from the core database engine. This design enables seamless integration with high-performance vector indexing libraries such as USearch and HNSW. When vectors are inserted, they first enter an in-memory buffer on each T server. From there, they are flushed into the vector LSM, where both in-memory and persisted vector indexes are created using efficient libraries like USearch. This process ensures both low latency writes and fast query performance. During search, YugabyteDB executes parallel and distributed queries across shards in the YugabyteDB. It is called as tablets. Each tablet uses its local vector index, which is powered by HNSW to compute top k nearest neighbors. The partial results from all tablets are merged to form the final response, enabling massive parallelism and linear scalability as nodes added. System level failures further enhance performance using automatic tablet splitting, which ensures that no tablet becomes a bottleneck as data grows, and adding more T server provides horizontal scale out for both storage and compute. In addition to speed and scale, YugabyteDB ensures strong consistency and fault tolerance. It leverages multi-version concurrency control, that is for accurate reads across distributed data. Read-based consensus and wall, that is write-ahead logging, ensures durability and high performance even during failures or outages. YugabyteDB's vector indexing architecture combines distributed Postgres-compatible execution, high-performance vector search using libraries like USearch and HNSW, strong transactional consistency, fault tolerance, and resilience. This makes it a powerful foundation for enterprise-scale AI application, delivering low latency vector search over billions of embeddings, all within a unified distributed database platform. This slide shows how YugabyteDB supports AI features like smart search and chatbot responses by combining two key components: searching through vector search and SQL. YugabyteDB powers RAG pipelines by combining vector search and SQL in a one distributed resilient platform. It auto shards data across node for horizontal scalability and provides high availability as well. As your data grows, YugabyteDB automatically spreads it across servers to keep things fast and responsive. It stays online even if some servers go down or there is heavy traffic. In a real world example, like a customer support chatbot, the system finds the most relevant information from sparse documents and feeds it to the AI, which then responds accurately and in context. YugabyteDB handles all of this in one place, so you don't need to manage different platforms or systems, just one reliable, scalable platform that powers smarter and faster apps. Take an example, consider a telecom plan recommendation that features personalized offers driven by hybrid vector relational querying. Imagine you are a premium postpaid customer in Europe, opening the telecom app. Instead of shifting through generic offers, the system uses your historical usage, including roaming frequency, streaming behavior, and typical call duration, to generate a customer embedding. Then it runs a hybrid SQL plus vector query, filter by postpaid segment and European region using SQL, and sort by vector similarity to that customer embedding under the order by embedding a customer embedding clause. This result is 5 mobile plans most semantically aligned with the customer's usage, not just keyword matches, but deliver instantly from a SQL, a single SQL engine with no separate vector or and a relational DB required. This approach enables telecom providers to offer efficient usage-based recommendations at scale efficiently, accurately, and all from one platform. Let's move on to check available vector databases and their comparison with VectorDB, that is YugabyteDB plus pgvector. In today's AI-powered world, choosing the right vector database is critical depending on your use case. Then architecture, then scalability needs, and development workflows. On this slide, I have categorized the ecosystem into three main quadrants to simplify the selection. First is SQL embedded vector stores. On the left, we have familiar relational and NoSQL databases like Postgres, YugabyteDB, Redis, OpenSearch, and Elasticsearch. These integrate vector search capabilities via plugins like pgvector or native models. They are perfect if you need hybrid queries combining structured SQL and semantic similarity and already operate in an SQL native environment. Second is dedicated managed vector databases. In the center, there are databases built natively for vector workloads. Solutions like Pinecone, VV8, Quadrant, and Milus and ChromaDB offer scalable high-performance search over billions of vectors. These are production ready for LLM, RAG, and multimodal search use cases, often with cloud-native deployment, index strategies, and metadata filtering built in. Emerging OSS vector database on the right side are lightweight or fast evolving open source databases. These are ideal for developers experimenting with a local first LLM memory, fast prototyping, or embedding visualizations and maturing. So depending on whether you are building on existing SQL systems, scaling dedicated AI infrastructure, or experimenting with open tools, these landscapes offer a clear guide to where each solution fit. Now, let's compare vector databases with YugabyteDB's integrated vector search capabilities. We'll compare feature by feature. First is vector search. Both systems support vector similarity searches, but YugabyteDB aims it in distributed SQL engine, not a separate service. Second is horizontal scalability. Standalone vector DBs can scale, but YugabyteDB inherently shards vector indexes across tablets for linear scale and throughput. Third, vector DB resilience depends on vector SLAs. However, YugabyteDB offers wrapped-based replication and geo-distribution, ensuring continuous availability. From the consistency side, YugabyteDB provides strong distributed consistency via wrapped, while standalone systems may offer limited guarantees. Standalone vector DBs generally lack rich SQL support, but YugabyteDB offer ACID SQL joins, filters, and aggregations. Point number 6 is YugabyteDB supports multiple data models, including relational, vector, and document with full ACID compliance, unlike specialized vector stores. Point number 8, both systems can handle high query volume, but YugabyteDB uniquely supports SQL filters with vector queries, a critical feature for real-world AI applications. The ninth point is standalone system may offer geo availability, but YugabyteDB provides it natively. It, of, it also supports hybrid multi-cloud orchestration and is fully open source, while most standalone DB vectors are proprietary or offer limited openness. In summary, while standalone vector databases excel for pure similarity workloads, they fall short when you need real-world features like relational queries, global scale, strong consistency, and observability. YugabyteDB addresses all this seamlessly, making it the ideal unified platform for production-grade AI applications. Now let's see this in action. I will show the hands-on demo and run a hybrid query that combines a vector similarity search with the relational filter. In this demo, we have built a semantic movie recommender system using AI and vector search. Let me first show you the Python script. This script creates the PG vector extension and a table with a column of vector data type and creates an HNSW index. The script loads the movie data set and searches the vector data set based on the user queries. The data set is in CSV format. I'll show you the CSV. So this is a bigger file including few of the columns which we are inserting into our database table. So let me first run the script. So this will take some time to load the data. Then I'll come back to this screen again and explain the output. Here is what we are doing and why. We are using the TMDB, that is the movie database of the 5000 dataset, which you can download it from the Kaggle site or other sites. It includes movie overviews, genres, release dates, and ratings. We use semantic embeddings from a transformer model to capture the meaning of the text. These embeddings are stored in YugabyteDB's vector of 384 dimensional columns using the PG vector extension. We create an HNSW index to enable fast approximate nearest neighbor search. But we don't stop at similarity alone, we combine it with SQL filtering. For example, we only want to recommend highly rated movies whose rating is more than 7.5. That's why this is called hybrid search. It blends semantic similarity with structured SQL filtering. Let me go back to the Python script output. Okay, data loading is completed. Now I can run a user search query. First, let me ask, I'm looking for a movie where humans battle aliens in outer space. The system returns the top 5 movies with ratings above 7.5 and based on the user query. Let me run another query. Looking for a sci-fi action film with intergalactic warfare. Again, the system returns the top 5 movies matching that user intent. Our goal is to deliver accurate, semantically relevant recommendations, focusing on meanings, not just keyword matches. And we have achieved using YugabyteDB with PG vector extension. Let me go back to the presentation. Okay, to wrap up, here are the key points from today's session. YugabyteDB unifies relational and vector workloads, allowing you to run advanced AI and transactional queries together at scale in a single platform. Its distributed architecture ensures you get high performance, resilience, and global availability, making it ideal for enterprise AI applications. By eliminating the need for separate vector and SQL databases, YugabyteDB simplifies your data architecture and accelerates innovation with features like the Vector-LSM storage layer, USearch, HNSW, and observability. YugabyteDB is ready for the next generation of AI workloads. So thank you everyone. Thanks for your time.